Hello to viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about a lot of news, aka Steam controller, machine and frame. So let's dive deep into it. So before we dive into these devices, we have to understand their creator, aka Valve. Now you have to understand that Valve is a corporation and they have a subdivision known as Steam, and this is their main, money maker, so to say. It's basically online, basically digital only, most of the time digital only market share, where people can actually share. Basically different publisher will publish their games into that market store and people will buy it from them, and Steam will take a small amount of cut from it. And they have been a bonkersly successful, as in like there is almost nothing like it. Like legally speaking, they're almost at the point where they can legally be classified as monopoly, simply because they do not have any monopolistic practices. That's why it's not mattering. It's basically like there are 5 to 6 companies and none of them give service half as good as Steam. So and they just announced a lot of new hardware. Basically they are branching from software only to hardware, and the target point, let me figure, this is just an announcement, this is not a launch, because again you can't buy it. The target point is Q1 to Q2 in 2026, so it's few months away from now. And one of the unique point that Valve has that no other gaming company has. I used to work in a gaming company and I can tell you, like, most gaming companies are owned by stockholders, and they are people with money, but they're not people with wisdom of that industry. It's almost like, if you have a stockholder meeting in Boeing, and they will say, of course they will say, hey, why do you have 2 safety instruction? Fire 1 safety instruction, they're redundant. It's like, yeah, happened. So Valve is safe from that. Why? Because Valve is what we call privately owned, meaning few people own it. Like, it's not in public stock market, you cannot buy for it, it's completely self-owned, meaning they do a service, they get paid from it, that's it, the end. It's almost like a mom and pawn shop, of course, billion-dollar industry scale, but still completely private. The other big player in terms of private would be SpaceX, completely private. So they are free from stock market demand, meaning legally they do not have to answer to anyone, meaning if they want to burn money on some experiment, they can. Other companies are like, okay, you only get 1 year to experiment, and if it does not work, we're gonna kaput it. No, they have that sort of freedom that other companies just do not have. And they are now entering a space which is basically console, virtual reality, portable computer, and Linux box. Basically they are expanding their portfolio without introducing too many new devices, but they are expanding the portfolio in such a way that should have all of these public covered, and it will allow them. What's the biggest benefit why they are doing it is because vertical integration, meaning you need to have access to a marketplace. Let's say that marketplace is called Steam. Cool, awesome, GG. They started with few games, basically Half-Life, Portal, and Counter-Strike. That's how they started. Now they are like, if it's not in Steam, it's not actually doing too well. So that's how they started. But here's the deal. How do you play Steam? You have to have Windows. You have to have a computer. So there is 2 layers of things that has to be done. You have to have a computer hardware, then you have to have a Windows operating system, then you get a Steam. So there is a lot of friction there. What if you have Steam hardware itself? So that's what they are trying to do, have a complete vertical integration. So basically like how Sony makes a PlayStation and then they hire studios to make PlayStation exclusive games, and that's how they maintain a closed circuit economy. They want to also do the same thing. It's like, hey, we have a marketplace, and in that marketplace you can buy games. Okay, people are like, okay, cool, awesome, I bought a game, where do I play these games? Hey, we have hardware portfolio also where you can play these games. Vertical integration. Ironically doing in different direction. Most companies like, okay, game to marketplace. It's like, no, hardware to marketplace. Games, whoever makes it, God knows when he's gonna make Half-Life 3, but that's the whole point. And this used to be the old logo, this is the new logo, and this is him very long ago, like 1998 kind of long ago. So it's a very unique and horrifyingly successful company. Like very few companies have this sort of, like, employee to yield ratio. So let's understand some history. Now, they have tried to do this in past because Gabe Newell had like very good experience with Windows, and again, that's how he started. All things were fine, but Windows 8 bitch slapped him, and he was like, no, you cannot bitch slap me, and he did, got bitch slapped. So he was like, okay, Windows is not gonna be a stable platform for gaming. This is during Windows 8 era, after Windows 7. So you can understand this guy was seeing far ahead, and he realized very early on is that Windows is the weak link, not the hardware, not the software. Windows operating system is the weak link. So he was like, okay. He tried to do something about it. He has money, so he's like, okay. He tried to do something about it. So he released this puppy as a option, alternate. The idea was Steam is gonna certify quote unquote computers and operating system that can take care of operating system. They're gonna make as like skinned Linux system, and hardware will be made by other manufacturers, including Alienware. So this sort of thing was made, and they made controller also for it. So basically it was a console PC that you could buy and that will work. But it did not work. Flat out, it did not work. Why not? Well, even though Steam was a big deal back then, it was not right. It was not ready. Pipeline was not great. Flat out, they wanted to do the same thing that they are doing now, but the ecosystem was not ready. As in, the idea was that you could simulate games into it. Yeah, that technology was not there. And be mindful, this is the era before 4 gigahertz CPUs were like normal thing. So yeah, soul was there. The horsepower was not there. So they're like, okay, the idea of partnering with vendors, that also did not work, because there was a lot of internal friction. That also they learned from. It's like, okay, if we have a lot of external vendors and all that, that does come with some consequences. It does reduce your exposure, but does increase some hassle, so to say. So they learned a lot. Like, that's why I'm saying that there is no failure, only lesson. They learned their lesson from this puppy, and then they're like, okay, they basically learned a lot, and then they started to work on software stack, because it was not the hardware that failed. This hardware, GG, awesome, shut up, take money. Actually, this was surprisingly good. Even today, like if you look at the packing layout, it's literally years ahead of its own time. As in mini ITX machine system, that's what they had. Like they were really ahead of their time. Cooling and all that, all those things were sorted. It's just that they did not have software stack. So they put their best people into this puppy. Basically have Linux, have Arch on top of it, and then work on Proton layer, wine layer, so to say. So idea is Windows game should just run. Windows game, click, install, go home. That's the whole point. And they worked years on it, years, refining the core back end of it. And after a while, when they thought that it was ready to launch, then they released this puppy, Steam Deck. Now, Steam Deck was very shocking, because again, right now on YouTube, this is not that long ago, like 3 to 4 years ago. So you can actually see how people reacted to Steam Deck that time versus how people are reacting to Steam Deck now. Like when it came out, it was there, it was ready to work, but it was not polished. Basically, they got the core working, but it was not refined. And this brute forced it, make it polished. Basically, the game developer also did some work. Valve Studio also got a real world test data. It's like how the heck it's working. All of that allowed them to leapfrog the quality issues in around 2 years. Basically, the hardware, same hardware, 2 years ago, it's like barely working. Now it's like smooth. Basically, they went to from a point that whole library will barely work on this, to like almost all of the game will work decently when well into this puppy. And the only games that are flat out not work is simply because of anti-cheat software. Because again, anti-cheat software has so many layers to it. Some anti-cheat software goes into the kernel layer, and it's like, yeah, if it detects Linux kernel, it's like, nope. So those things are causing an issue. It's not that the protocol is an issue. It's just that there is a fundamental anti-cheat third-party software that is like, no. And it worked great. Like it sold millions of units. And be mindful, this is going against an era where no other portable handheld is doing that great. Sony used to make portable handhelds, kaput. Other companies used to make handheld, kaput. Nintendo is the only one that survived somehow. And this came into that market where people are like, hey, don't make handheld because everybody has smartphone. Nintendo already has whoever the edge case is. In that crowded market, this puppy landed. And so far, the data is they are reaching their 10 million units sold milestone. Now, is that a big number or a small number? For a first time handheld, is shut up, take money. That's not big number, that's shut up, take money. Now, of course, Nintendo has higher sales volume, but again, they have a legacy, like bonkersly long legacy. This is a brand new device with no games. Like remove Nintendo's basically IPs, intellectual Zelda, Halo, sorry, why I'm saying Halo, Zelda, Mario, those sort of like few target, you remove those games, nobody will touch the consoles. This is completely opposite. There is no game. The game you can play in PC, play well, better in PC, but people still bought it and it worked. So it was mind-boggling. Basically, all the learning from this, elbow grease from this made this a success. So this company does know what they are doing. So the first thing, Steam controller. Now this is Mark II controller because again they did release it. You could have bought it long ago, and I have no idea why they did not change the name. But again, this is Mark II Steam controller, and it does everything a PC gamer requires. Basically, PC gamers have what we call the master race, aka keyboard and mouse, the best controller system. Now, why this is the best? Well, try to play Satisfactory. You will understand. Everything else is easy. Try playing Satisfactory. Heck, bit easier. Try playing City Skylines. You will understand like why you need keyboard and mouse. So there's a different kind of expectation from a console that's supposed to be for PC gamers. So they made a controller that suits that need. And again, making Steam Deck, they learned a lot about it. So this has almost everything that a person would require and still be able to switch from keyboard mouse to this without too much hassle. Of course, it will not be butter, but it will be like, hey, I can get used to it. And again, they also learned this basically how to have trackpad, haptic engines and all that. They did learn this thing from their Mark 1 iteration. So this has all of that. Now, what do PC gamers require? Low latency, aka low finicky hardware. So how do you reduce finicky hardware? Do not use the normal common spectrum, aka 2.5 gigahertz in Bluetooth band. 2.5 gigahertz is the radio. The protocol is the Bluetooth. Everybody uses that. And if you use that same Bluetooth radio, which it has Bluetooth radio, meaning you can connect this to your Android phone and play with it, it will not be that greatest. It will work. It will not be greatest. You can connect it to Bluetooth over your motherboard. If your motherboard has that Bluetooth and Wi-Fi inbuilt, it will work. It will not be the greatest. So they created a puck system. Basically, that puck, again, is 2.5 gigahertz spectrum, but it has its own dedicated encoding, decoding. Why do that? Well, again, it reduces latency. And again, it does not have that only that works. Other things are also there. It's just that if you are happy with basically normal Bluetooth, enjoy. If you're not happy with this, we have this. Heck, if you're not even happy with this, you can even plug it and it will still work. They design in that way that it can work in all three scenarios. So again, PC gamer was at their mind. And puck itself has two-in-one role. Basically, what's the easiest way to destroy a controller? Destroy the plug. Once you destroy the plug, it's a very finicky to deal with. Don't have the plug. Have a magnet. It has a plug. Let that be very clear. It has a USB-C plug. You're just not supposed to use it. You're supposed to just plug the USB-C cable into the puck and plug supposed to put it down. Magnets will clamp into it. Done. Go home. Sweet dreams. So they design in such a way that is a very what we call friction-free experience. I wish my Logitech Master Mouse had that. Like it requires a USB-C jacking. This is much effective for charging, far more effective. So they did that. And because again, there are still 1 or 2 games made that has multiple player. So one of those puck can handle 4 players and one PC should be able to handle 4 pucks. Now, like why that limitation is there? Generally USB controller and device ID, most likely that is internal limit of them. So that is also there. I remember like when I used to be a 3D game artist, we were studying. One of my friend got a bonkers PC, like bonkersly high powerful PC, dual display monitor and all that. And we used to play Blur, car racing game, split screen, 4 people, 4 controllers. We were doing that. We no longer see that sort of ecosystem, but it was doable. So this could do something like that. And this time they listen to the audience and they are not like Nintendo where they're like, let's F the public. So they're like, hey, what is the biggest complaint of this sort of thing? Joysticks. Well, joysticks is physically a wiper going on a carbon resistor. It will wear down. Now, of course, it will not do that in one day, but over a few months, it will. Nintendos are really bad. Xbox does have some reliability, so does Sony, but eventually, it's a physical thing, it's gonna wear out. So what's the alternative? Is there a solution? Yes, there was a solution. Known as Hall effect system. Basically, you have a magnet and you have a Hall effect. They do not touch, but they digitally transmit the resistance and tada, it works. Basically, the magnet rotation affects the resistance that is read by the electronic controller and tada, you get your position sensor. Awesome. Why didn't everybody? Company wanted to cheap out a lot and they do draw a bit more power. So this company is like, okay, let me flex. So they went to tunneling magnetoresistor sensors. Basically, it's a quantum technology that is ahead of Hall effect sensors. Hall effect is ancient, as in like old IBM PCs, they used to have Hall effect keyboards. It's ancient technology, like Soviet Union had that kind of ancient. But they do have very low resistance, meaning it does have high current draw. While tunneling magnetoresistor, this puppy, basically TMR puppy, that similar sort of properties, but they have like, one ferromagnetic material insulator that is like, few atoms thick. Yeah, that's why it's like it works on quantum properties. And then another ferrite. So based on magnetic field alignment, resistance changes a lot. like a lot. Like you have lot of precision. Like you're like, I can see you. Like in normal Hall effect, it's like, this is like, I can see you. Very smooth. Lot of precise, lot of resolution. Everything is there. And because the resistance are bonkersly high, the current draw is magnificently little. Like 100 nano amps. Like it's magnificently nothing. Basically, your battery's self-discharge is that high. So that's how it works. So not only you have something that is better than a Hall effect, you have something that has higher resolution than Hall effect. So they are flexing. It's like PlayStation could do that, Xbox can do that, Nintendo can do that. They are charging a hell lot of money for that device, but they're like, no, let's F the customer. Steam is like, hey, what if you have a controller that you can keep using and it does not have an inherent part that is like, what you call limiting part, basically. Limited lifespan, sorry. Yeah, limited lifespan. And then another thing, battery. They have big battery. And this made my nerd self very happy that they are using the right unit. How big is the battery? 8.3 watt hour. That's how you're supposed to measure a tank capacity. Watt hour, not milliamp. I do not know the voltage. Watt hour. That's good. Now, is that a good thing? Yes. Why? Well, the battery, in contrast to what others are offering, is actually big. Now, why does that matter? Big battery means degradation happens slower. If you have a device that has a bigger battery and a device that drains less power, that battery will last years after heavy use. If you have a smaller battery, because again, they are giving 35 hours of battery life. What does that mean? That simply means this puppy is consuming little power, very little power. And it has haptics, it has basically touch panels, it has capacitive panels, it has everything under the sun. And they're still consuming so little power. So the battery is big, the draw is so little, meaning even if you buy this today and use it, like keep heavy using it, like heavy using it, even after a few years later, it still should be useful. So it's a really what you call, somebody spent time into designing. Again, ergonomic is a personal thing. Some people will love this, some people will hate it. There is no bad blood into that. But other things that are supposed to be you are putting effort into it. Hey, having a puck that does double duty, awesome. Having a magnetic clamping system that makes your life easier, awesome. Having tunneling magnetoresistance. Now let that be clear, this is not a new technology. You can buy third-party Xbox controllers that have this. It's more expensive than basically basic controller, Hall effect, magnetoresistance. This is the first party offering that has this. Like I would wish Nintendo do that, because like how ludicrously expensive the tiny things are, and again it wear down so quickly. This would last forever. So this is Steam controller, and I'm like genuinely like somebody put some effort into it, not just like, what if we saved 5 cents from this part? It's like, no. What if you don't? What if your people have a device that they can keep using for decades? Light use. Then we come to Steam Machine. That was the first offering. This is second offering. Tailor-made PC for average gamer. Let that be very clear. This is not for you and I. There are a lot of people who get used to watching Linus Tech Tips and all that, and they think every Tom, Dick and Harry is going there like my big 1490. Yeah, most people don't have 1490s. Okay, let's come down to earth. Heck, I only have like... again, I did not pay for it. That's why I have this sort of a computer. Is that it's a 12-core AMD 7000 series, and GPU is 4070 Ti 12 gigabyte VRAM. Most people don't have that. Now, how does Steam know that most people don't have that? Steam survey. So they have a real world data, and their data says that they can make a system that is not like GG, and they'll still be able to sell a lot because most of the customers are in that band. So they are targeting those people. They are not targeting the flagship users. They are targeting the users who are already using Steam, and their most hardware still running full HD display. Most hardware still around 4 or 6 gigabyte of VRAM. So that's what they are focusing on. And it's just from a practical point of view, think in this way. If you are playing Steam Deck, because Steam Deck was the first hardware, they want you to expand into it. Basically, hey, I bought Steam Deck, cool, awesome, GG. What if I dock it and play with it? It's like, okay, how would you know how many people are docking? They know Steam telemetry, 35% people are doing it. So people have a hunger for it. It's like, what if this could become more powerful? That's what people want. And Steam is like, hey, I got you. So that's how you have to think about it. Think this puppy is not like, gonna replace my big daddy computer. This is like, hey, it's just a box. If you have that handheld, what if that handheld was more breathing room? It's like, so that's the philosophy of it. Do not compare it to like, 5090 Ti or something like that. That's not the intent of this. So this has AMD Zen 4 Again, not latest and greatest, but not also bad, like really good system. 6 core, again, more than decent. And then you have AMD RDNA 3 28 core units, which is again RTX 7000 series GPU logic. Nothing flagship, but nothing bad also. It's decent. And this puppy comes with 16 gigabyte of VRAM. 16 gigabyte of system RAM, which again is actually large for a gaming system, but again, breathing room. And it's a sodium, so in principle you should be able to upgrade it maybe to 32. And then it has 8 GB of GDR6 VRAM. Now a lot of people are, oh, 8 GB is not enough. Here's the deal: 8 GB is more than enough if hardware is locked, meaning being as a game developer, we used to work on, like I worked in Forza. In that Forza, when I was making an asset, we had a different computer known as DevKit. Basically, transfer it per force. We are using per force, transfer it into this, and then transfer it into the DevKit and run it. So we can always monitor how much VRAM that asset is consuming. And of course, there were a lot of what you call conjuring had to be done in order to make sure the whole game fits into that system. Nobody does that anymore. That's why your VRAM draw is so high. Like compare the Crysis 1 to modern game. Crysis 1 still looks like the world looks rich, even though the whole VRAM budget is tiny. Why? Because somebody put effort into it. Nobody wants to put effort into it. It like you can easily tell where some game developer actually sat down and put effort versus is like just put asset. Oh, it's overloading. Let's like just remove assets. So now like whole Far Cry looks like, empty vessel, so to say. There are like a lot of things. And if you can have a hardware, and let's assume they sell 1 million of it, that means more than enough studio will buy this and just like, okay, let's just make sure it runs on it. If they did that, it will work smooth. What if they sold 5 million of this? Every studio will do that. 10 million, it would be stupid of them to not to do that. At that point in time, this 8 GB and 16 GB, that's shut up, take money. Shut up, take money. At that time, it won't, oh, but it can't do 4K. Who cares? People are replacing it with cheap computers. So more than good enough. Again, Steam average gamer, not flagship Linus Tech Tips gamer. Basic, average. So they have their own operating system, SteamOS, which is Arch-based. And again, this gives them the advantage that even on the same hardware, they can reduce the latency because they do not have the whole stack of Windows. And again, how bad Windows stack is? Windows worked with Xbox team to strip down Windows, and it was like so big on a handheld, ROG Ally handheld, and they're like, hey, if we have Windows running into it, it drains 2 GB of RAM or more if we just strip all of those things. Windows still work, all the drivers still works, all the installations, 2 GB of RAM just for bloat, just 2 GB. This is like, bro, nothing. They can shrink the operating system to megabytes and have like whole gigabytes free for game. So it can do a lot of things. So NKED Plasma is the what you call desktop environment. And one of my personal favorite, this I do respect Apple engineers for that, is that they always put power supply in the goddamn device. I hate this sort of a Lenovo 1 liter PC, Dell 1 liter PC, HP 1 liter PC is like, oh, it's a 1 liter PC. No, it's not. Your power brick is bigger than the goddamn PC. So having the power brick integrated, yes, it's a bit more expensive solution. Benefit, it's far more classy, far more logical. This is the box, the end. It's not like Xbox where it's like, oh, this is the Xbox and this is a huge power brick. No, this is it, the end, go home. I like that. Although I have no idea why it does not have earthing, but I've seen like there is a trend nowadays that almost even metal body objects are not getting earthing. Something happened, but that's what they're doing. So power supply is inbuilt into it. And it's a big power supply, like around 250 watt capable. So it's a big puppy. And the whole idea is they have only one big thick cooling fan to cool off. That's why the fin stacks are so kind of gappy. Compare that to like desktop system, you will find, hey, the fin gapping is like, heck, Evo coolers have, tighter finish because again, they're expecting higher push flow through the fans. There it's like pull. The fan is pulling air out. So half of the air is coming from the bottom, cooling the basically subsystem, specifically the power supply, and the top, which is cooling the CPU and the GPU. And they're pulling the heat out. And they have a place where you can replace the basically M.2 SSD. This I have to say, Sony made it kind of awesome and easy. So this is also there. It's a very, what you call, logical device for people who just like, hey, I am happy with the Steam Deck. I only wish it was more powerful. And to flex, like this is a Linux system, they have somebody developing Unity game into the goddamn system. And yes, it can do that. Heck, even has dual display port. Although weird, it will be expensive for people because one has DisplayPort, one has HDMI. My monitors rarely come with HDMI because again, you have to pay for it. Monitors always come with DisplayPort. So you can connect one monitor, one TV. Both monitor and TV is like, of course, there are more than enough monitors that have both, but you can connect two of them, have fun with it. So it's a really decent system, not whoa, but it's like decent, practical, logical. Buy it, put it, enjoy it, forget about it. And it also has micro SD card, meaning you can pull out the micro SD card from your Steam Deck, put it here, play the game. The end. The end. There is nothing more than that. So this is Steam Machine. Surprisingly good offering. Again, money unknown because again, tariff, RAM chip shortages, blah, 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 lot of things. So we'll discuss once that is announced again. Now we come to Steam Frame. Now, this is basically untethered VR headset with a PC inbuilt. Basically, this puppy has a computer built into it, basically a smartphone built into it. And the tracking is inside out. Now, generally people prefer outside in tracking. Basically, you have base station and that base station is basically observing the trackers on your body, be it the controller, be it the headset. And that's how they work. Now, they are far more reliable, but hassle. It has too much hassle. You want to make money, thou shall reduce hassle. So they reduced hassle, put the camera inside it. So it's doing inside out tracking. And to do all those crunching, it has Snapdragon Gen 3 processor, aka kind of decent SoC for like mobile phone with 16 GB of DDR5, decent RAM. And to make sure that you can stream your game from your computer or flagship computer or even a Steam box into this puppy, they have this dedicated wireless transmitter. Why? While wireless transmitter on paper is very awesome, in real life it's garbage. Same thing that happened with the puck. They had to develop a puck to reduce the latency. They had to do the same thing here. Instead of using 2.5 gigahertz or 5 gigahertz, they jumped to 6 gigahertz. That's the third Wi-Fi frequency available for public. That frequency has very little interference and very thick, I mean like double C kind of thick bandwidth. So it can actually transmit display signal without too much hassle. But here's the, they are smart. They know. On paper, calculation would be like, it's gonna give you 5 Gbps. Real life would be like, dude, you're lucky if you get 1 Gbps. So what did they do? They're like, hey, our eyes are needed to see things. It's like, whoa. They're like, bro, what if eyes are the only thing that are seeing things? I'm like, damn. So that is what we call a foveated render. Somebody figured out that our eyes had to be there in order to see things, meaning our eyes have a point, right? And that point, whenever that point is going, your eyes is only seeing that point. Your brain is literally filling in the blanks. So those fill in the blanks can be very low resolution. So the idea is you're gonna get like, let's say rendering quality would be 100% on the point where your eyes are looking. That's why there is an eye tracker on this device. All other devices, they will crunch the bit depth. Basically, let's just say your focus point could have very high bit depth, right? Because again, this is happening on a video stream layer. It's not happening on the game engine. Game engine, that happens with Sony because again, they have the complete supply chain. This is not going that deep. This is going to the streaming layer. Basically, your GPU pumps out the full system, but to make sure that you can actually get the full stream without basically latency or lag or glitches, this takes the frame, calculates your last known position of your eye tracking, and then puts everything else. Basically, this frame is 100% resolution, full color depth 444, and everything else becomes like 420. Just one way. That's the easiest way they can reduce the bit bandwidth requirement. Meaning now the pipeline from here to here is very low, but you can see same fidelity as if it was like full high resolution. Why? Because your eyes had to be seeing there. Like your eyes have to scan everything, and by the time you're doing it, you are moving it. So there's some realize that our eyes have a limiting factor. Our brain fills in the blocks. That's why we do not see spotlight. Your eyes is filling in the blanks. That's why you don't see holes in your eyes, because even though we call them blind spot. There is a hole in your retina and your brain is like, I got you fam, let's paint over it. So that is what foveated rendering does. So far it's a really decent system, and it has the ability of having a PC built into it. It has a micro SD card, and yes, in principle, you should be able to pull out the micro SD card from your Steam Deck, plonk it into this, and play the game as if it was running on a virtual large monitor. You should be able to do that, and you should be able to side load APK. Damn. Now, so far, so good. I'm not that excited about that. But here's the money shot. They are working on a translation layer for x86 to ARM. That is a big deal. Here's the deal. This guy literally looked into Windows future and is like, yo, Windows is not gonna work. We gotta change it. How did it change it? Did it like, made Game Studio and all that? No. It's just like, what if we change the layer itself? Kaput the layer. x86, cool. Windows layer, throw the Windows layer. Put a Linux layer on top of it, put Proton layer on top of it. Done. Go home. It's like, what if you can throw away the x86 also? So that's what they are working on now. As in, this would be their last, the recent large-scale project. Meaning, so that's a big ask to make sure that everything that Windows x86 stack, like DirectX 11, DirectX 12, DirectX 9, all of those things work, and all of the audio drivers, video driver, they can work as if native. That is a big ask. Forcing all of that to go through a translation layer, still work on ARM hardware, damn. Like, that is so difficult that Windows is trying to do that and pooping itself. Windows is working with Qualcomm and they're still pooping themselves. And Valve is like, allow me to fix it. I'm like, damn. That is a big damn. Like, everything else are like, okay, cool. This is like, holy damn, they are planning long ahead. Like, how long ahead they can plan? Well, imagine this way. If they have a translation layer for this whole stack, as in, oh, is it working on Windows or Linux? They get it to Linux, meaning now they control the stack. If like, okay, but x86 you still have to work with Intel and AMD. It's like, no. I got the ARM. What is the next step? Yeah, they have their own CPU built. How can they do that? Well, right now most CPUs are either x86 or ARM holding designs. Basically, Apple has to pay ARM holding bonkers load of money to get that core designs. And of course, they add some butter masala to it, but core design they have to buy. That's how ARM's holding is very rich. But what if there was a different instruction set architecture and they are learning this protocol? So basically the translation, so they can switch that also. Because again, once you can jump from x86 to ARM, which is the biggest jump, why? It's going from sys architecture, as in complex instruction set architecture, to reduced instruction set architecture. That's a big jump. If they can do that, going from one type of RISC architecture to another type of RISC architecture, it's minor inconvenience. So ARM holding architecture that we use, ARM systems, that's good, that's a risk. But there is another risk that is open source, which we call a RISC-V. So Steam is planning so far ahead. It's like I can actually see them like, few years from now, like, yeah, oh, RISC-V hardware is now good. Let's switch everything to RISC-V. They can do that if they figure out this translation layer. Heck, if they figure out this translation, that they can have Steam on your mobile phone. Think about it. Oh, you bought your new flagship S27 Ultra, GG. Install Steam into it and play all computer games into it. That's a big shot up, take money. So this is the biggest news. All this, cool. This, holy damn. Like, imagine a world where you have a Raspberry Pi and you're just like, future Raspberry Pi, not current Raspberry Pi, but future Raspberry Pi, and you're just like, oh, I'm installing Steam games into it. That's a big jump, like, big. So I have to say, like, bold company. I have to say, like, bold. So this was a presentation on Steam's offering that is happening right now. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.